Hey guys, in this video we're going to talk about Chapter 2, Section 6, Systems of Linear Equations. So, a system of linear equations is just one or more linear equations in the same variable. And this terminology is new, but we actually did this in the last video. So last time we looked at solving a system of two linear equations, or two lines if you like that, graphically and algebraically. And so let's just remind ourselves how we did this. If we wanted to solve this system right here, we would simply plug in each line into Desmos and look at their intersection. That's how we did it graphically. So we have 2x minus 1 and 3x plus 9. So we plugged these in Desmos, and then we zoomed out until we found where the lines crossed, where their intersection point was. And we found their solution that way. We said, oh, well, x is negative 10 and y is negative 21. So that's how we did it graphically. Algebraically, we set these guys equal to each other. So, since y equals this and y also equals this, these two things must equal each other, right? So algebraically, what we did is we said, well, y, 2x minus 1 equals y, which is 3x plus 9 as well. And then we solved this guy by finding x. So we could subtract 2x from both sides, and we get negative 1 is equal to x plus 9. Then I'll go ahead and subtract 9 from both sides to get x is equal to negative 1 minus 9, which is negative 10. And we indeed got that graphically. So that's how we can solve a system of linear equations. And when it says when they're in the same variable, if we look at these two lines, each of these lines involves x and y only. There's no other variables. So that's what we mean by the same variables. So we're going to look at more examples of doing this where maybe y isn't isolated like it is in both of these lines. Maybe we have to do some manipulation. We're going to look at other strategies to solve these things. We're going to look at substitution, which we've technically been doing. We substituted both of these things in for y and solve for x, but we're going to do some more sophisticated substitution, as well as another method called elimination. So let's just do some more review with this. So we talked about how there were three different options with a system of two linear equations. We talked about the first option being a system with one solution. That's the example we just did. They cross exactly in one spot, and that spot where they cross is the solution. And we've done plenty of examples where we look at what the spot is graphically. So how would we write the system? Well, we could write it like this. This little guy right here is called, some people call it braces. It's just kind of like, it just means a set. So like this is just saying, hey, this is a set of two linear equations or a set of two lines. So we can use a substitution by setting these guys equal to each other, because the whole thing, it's actually called transitivity. If A equals B and B equals C, then A has to equal C. So like if two different things equal the same thing, those different things have to equal each other. And that's what we're doing here. So x equals y, but also negative 2x plus 10 equals y. So the y's have to equal each other. That's what transitivity is telling us here. And so we can go ahead and solve for x. I can add 2x to both sides to undo that subtraction of 2x on the left. And when I do that, I get 3x is equal to 10. And I'll go ahead and divide both sides by 3 to get x equals 10 over 3. Now, so that's going to be this point right here. So this is our x. Now to find our y, we can plug in x into either of these equations. If I plug it into that one, that's super easy, because if I plug 10 over 3 in for x, I get out 10 over 3 as well for y. So that's the point of intersection. Now you could have plugged in x equals 10 over 3 here, and you would have gotten y equals 10 over 3 there as well. So that's the one solution case. That's an example. We also talked about systems with no solutions. So that means that we have parallel lines. They're never going to cross each other, and so they don't have a solution. They don't share a solution. We also talked about a little cheat code. We talked about how if two lines have the same slope, aka the same steepness, but different y-intercepts, then they're not going to have a solution. So in this case, we can see that both of our lines have the same slope of 3, but different y-intercepts. The blue line has a y-intercept of 4, and the red line has a y-intercept of 1/2. So we know right off the bat these are not going to have these are not going to share a solution. We can also see this algebraically. So if we set these guys equal to each other, we get 3x plus 4 is equal to 3x plus 1/2. And if I try to solve for x, I can subtract 3x from both sides. But what I end up with when I do that is 4 equals 1/2, which is a false equation. So that's how we know algebraically that there is no solution. The third case that we talked about was a system with infinitely many solutions. So that's when we have two lines that are secretly one line, right? So the blue line is y equals 3x plus 4. That's already in y equals mx plus b form. But with the red line, if I look at this red line and solve for y, if I isolate y to get it in y equals mx plus b, I divide both sides by 2. I divide everybody by 2, and I get y alone. And 6x divided by 2 is 3x. 8 divided by 2 is 4. And so I can see now that, oh, that was the same line all the time. And when that happens, when you have the same exact line, you're going to have infinitely many solutions. We can also see this algebraically by, now that we have y isolated, we can set these y's equal to each other. 3x plus 4 equals 3x plus 4. Solve for x, subtract 3x on both sides, and I end up with 4 equals 4, which is a true equation. So since I get a true equation at the end of the day, I know algebraically that there are infinitely many solutions to this system. Alright, so let's do an example here. What is the system of equations shown? And we're given 3 different options. Now, notice that the options all have x's and y's. And so I know that all of these, even though they're not in y equals mx plus b form, they're disguised. And we can do some manipulation to put them in y equals mx plus b form. But before I do that, I want to actually get the equations of the lines themselves. If I have the lines, I have the system. So I'm looking at the red line, and I see that b is equal to 2. So that's our y-intercept. That's where it crosses the y-axis. And the other thing we need for the equation of the line is our slope m. And for that, we can do rise over run. So we know b is equal to 2. For the slope, I can look at this point, and I can say, well, how much do I rise and run? I'm going to rise 1, 2, plus 2, and I'm going to run 1, 2 to the left, so that's negative 2. I rose up and went to the left, indicated by the negative. Rise over run is going to give us a net value of negative 1, right? Positive 2 divided by negative 2 is negative 1. So, therefore, my slope is negative 1, and the equation of the red line is y equals m, which is negative 1, times x plus b. So this is the equation of my red line. Let's get the equation of the black line, and once we do that, we'll mess around with these and put them in y equals mx plus b form. Alright, so let's look at the black line. The y-intercept is pretty clear on here. It's negative 4 because that's where it crosses the y-axis. And we can do slope. So really I can just do these 2 points. They're right next to each other, and I see I'm going up 1 and to the right 1, indicated both positive. So rise over run is going to give me a net result of positive 1 for my slope. So therefore my equation of the black line is y equals m, which is 1, times x plus b. So this is my system, and we have to figure out which one of these is actually this in disguise. And to do that, we just do some algebraic manipulation to get y alone. So let's do that for A. I'm going to go ahead and manipulate this guy first. So I start with 3y plus 2x equals 2. And I'm going to go ahead and draw my line through my equal sign. So to get it in y equals mx plus b form, just like we have up here, we want to get y by itself. So to start that process off, on the left, I'm going to subtract 2x from both sides. And I guess maybe I'll do this down here. Let's see. 3y plus 2x equals 2. Let's get rid of this up here. So again, I'm just trying to get y by itself to see if it matches these lines that, that make up the system. So let's go ahead and subtract 2x from both sides to get y alone. And then I'm left with 3y on the left. On the right, I have 2 minus 2x. If I divide both sides by 3, I get y equals 2 divided by 3 minus 2 divided by 3x. All right, so this is in y equals mx plus b form. And if I go to my system, neither one of these has a slope of 2 over 3 or a y-intercept of negative 2 over 3. So right off the bat, I can say, no, this is not it. That doesn't match what we have up here. So I don't even have to do the second line in the system. I already know that since that line doesn't match either of them, that's not the right answer. Let's look at choice B. So choice B, the first line in the system is x plus y equals 2. And so what I can do to get y by itself is I can subtract x on both sides. And I get y equals 2 minus x. Does that match anything we have up here? Well, actually it does. It actually matches this guy, right? Because you can see the negative, even though it's written differently, even though the negative x is written second, the negative is still in front of the x, just like it is here. And the 2 is still positive. There's an understood positive in front of there. So these actually match up. So let's check the second one. So that one matches up. Let's check the second one to see if it equals x minus 4. Well, if I check the second one in the system, I get y plus x equals minus 4. I want to isolate y on the left, so I'm going to subtract x from both sides to do that. And I get y is equal to negative 4 minus x. Does that match this guy? Does that match this guy? Is it true that negative 4 minus x is the same thing as x minus 4? Well, no, because what's missing is the minus in front of the x. If it had a minus in front of the x, this would be correct. But since it doesn't, that's not right, and this is not our missing system. So even though the first line was correct, the second line wasn't, and therefore the whole system is not right. Well, by process of elimination, we know that C probably has to be the right answer, but let's prove it. So the first line in the system is 3y plus 3x equals 6. And again, I'm doing the same thing. I'm just trying to get this guy in y equals mx plus b form so I can compare it to my lines up here in y equals mx plus b form. And this negative shouldn't be there. Let's put it like that. Okay. Okay, so to start the process off, to get y by itself on the left, I can subtract 3x from both sides. And therefore, I'm left with 3 times y on the left equals 6 minus 3x on the right. Now, my last step is to divide everybody by 3 to get y alone on the left. And when I do that, 6 divided by 3 is 2, and negative 3x divided by 3 is negative 1x. So this is my line in y equals mx plus b form, 2 minus x, and that does indeed match the first one. So that is check. Now let's see if the second line matches the second line that we found. So we have 2y minus 2x equals negative 8. I'll draw my line through the equal sign, and my goal is to isolate y. So I'm going to start by undoing subtraction of 2x by adding 2x to both sides. And when I do that, I get 2y on the left equals negative 8 plus 2x on the right. And my last step is to divide everybody by 2 to get y alone. So that goes away. And I'm left with y, negative 8 divided by 2 is negative 4. And 2x divided by 2 is 1x, so that's just plus x. So negative 4 plus x, well, that is exactly this guy, right? Negative 4 positive x. Okay, so that's right. So it has to be choice C. That is our correct system here. Now, if you wanted to cheat, and I don't condone cheating, but I do condone checking. So you can check, you should know how to do this, but you can check yourself on Desmos by putting these in Desmos. Put in Desmos to check. And the beauty about Desmos is that you don't even have to rearrange anything. Like, I could literally put in 3y plus 3x equals 6 and get a line out. So watch this. 3y plus 3x equals 6. Oops. So zoom out. Oh, there's my line. Let's do the second line, which was 2y minus 2x equals negative 8. And I get my second line, and I can see my solution of x equals 3, y equals negative 1, just like we had in our original picture right here. All right, so that's how you can check yourself. Okay, what is the system of equations shown? All right, so all we have to do is find the equation of these lines, and we know how to do that pretty well by now. We know that the first thing we need is the y-intercept. So here we can see the y-intercept is 7. So my b for that blue line is 7. And we can see for the dark blue line, my y-intercept is 1. The last thing we need for each of these is the slope, rise over run. So if I look at, this is a nice point because it's in the corner of the square. If I look at that point and start at the top point, I go down 1, 2, 3, so I go down minus 3, and then I go to the right 1, 2, so that's going to be positive 2, and therefore my slope rise is negative 3 over run positive 2. That gives me a net result of negative 3 over 2. A negative over a positive is negative. So therefore my line for my first equation in my system is y equals m, negative 3 halves, x plus 7. Okay, let's get the equation of the second line. Well, I'm looking at this guy. I see the y-intercept is a nice point, and I can grab this point over here to do my slope. From the y-intercept, I go down 1, 2, 3. So I go down minus 3, and then I go to the right 1, 2. So again, I have rise negative 3, run positive 2, gives me a net result of a negative. So my equation for my second line is negative 3 halves, x plus 1. So this is my system. This is my answer right here. And we can confirm that this system has no solutions. Firstly, we look at the graph and we say, oh, these are parallel, they're never going to cross. And second of all, they have the same slope but different y-intercepts. And we know from last time that that means that they're parallel. All right, how many solutions does the system have? So what we can do is we can do one of two things. We can look at this graphically. We can just punch it into Desmos, each of these in Desmos just as they are. Or we can do some algebraic manipulation. Now, since the y's aren't isolated, this might be a little bit cumbersome, but we're going to do it the cumbersome way, and then I'm going to show you a cheat code for how we can do this a little bit easier in a few slides. So, first thing we can check on Desmos, 2x plus 8y equals 6. Let's put it in. 2x plus 8y equals 6. So there's our first line. Let's put in our second line, negative 5x minus 20y. Negative 5x minus 20y equals, what was it, negative 15? Yeah. Negative 15. All right, there we go. Uh-oh. Guys, I think this thing has infinitely many solutions because I only see one line. So Desmos already says infinitely many solutions. But let's prove this algebraically. So prove it algebraically. The first line is 2x plus 8y equals 6. Now again, the strategy is to put this thing into y equals mx plus b form because we're trying to show that both of these lines are secretly the same line. And what better way to show it than to put them both in y equals mx plus b form? So to do that, I want to isolate y. That's my mission. So first of all, with my first line, I'm going to subtract 2x from both sides, leaving me with 8y equals 6 minus 2x. And now I'm going to divide both sides by 8 and simplify as much as I can. So on the left, I have y by itself, which is what I wanted. Now 6 divided by 8, if I divide top and bottom by 2, 6 divided by 2 is 3, 8 divided by 2 is 4. So that simplifies to 3 over 4. And negative 2 over 8 simplifies to negative 1/4 if I divide top and bottom by 2. And there's still the x. So this is my first line in the system. And by the way, this is equal to this. I simply rearranged everything legally, right, by making sure the seesaw is balanced, but it's the same line, right? So that's that line. And now I can do the same thing for the second line. So let's go ahead and do that. So my second line I have, and I know these two things are lines. I know that they're lines because I only see x's and y's. I don't see any other exponents on the x's or y's, so I know that these things are lines. Just a little side note there. All right, so I'm going to draw my line here. I'm trying to get y by itself, so the first logical thing to do is to undo subtraction of 5x by adding 5x to both sides. When I do that, I get negative 20y on the left equals negative 15 plus 5x on the right. Now my last step is to divide everybody by negative 20 on the left and the right, and to simplify as much as I can. So on the left, I'm just left with y, which is what I wanted. On the right, these two negatives divided make a positive, and 15 over 20 can be reduced by 5. So if I divide 15 by 5, I get 3 on top. 20 divided by 5 is 4 on bottom. So negative 15 over negative 20 simplifies to 3/4. And over here, 5 divided by negative 20, again, I can divide top and bottom by 5. And when I do that, I end up getting a net result of negative 1/4 x. And I just brought the negative like to the middle. If you wanted to leave it on the bottom, that would be okay too, but we typically don't do that. We typically just kind of leave it in the middle there. So again, I just divided 5 and 20 by 4 to reduce to 1 over 4. Oh, sorry, I divided 5 and 20 by 5 to reduce by 1 over 4. So, guess what, guys? This is equal to y equals 3/4 minus 1/4 x. Exactly what we got up here. So those two lines are secretly the same line. Infinitely many solutions. That's how we show that algebraically. Alright, so the figure shows the graph of one equation in a system of two equations. Find which of the following for which of the following equations does the system have no solutions? Okay, so no solutions. What does this mean? This means same slope. And maybe I'll do it with my letters. Same slope m, same y-intercept, or sorry, different y-intercept b. That's what that means. So let's talk out the strategy here. I am given a line. I want to find the equation of that line and then see which of these choices has the same m as the equation of that line, but different b. So that's what I'm trying to do here. That's the strategy. So first things first, I need to find the equation of this line. Now the y-intercept isn't very obvious to me. It looks like it could be 1.5, but it's not completely obvious. So I'm gonna have to find the y-intercept in a different way. I'm gonna have to do another step. I can find the slope pretty easily though, because I see this guy is a nice point because it's in the corner of the square, right? And this guy's a nice point. And so what I can see is that the slope, I'm going down 1, so this is -1, and then I'm going to the right 1, 2. So plus 2, and therefore my slope, rise over run, is going to be -1 over 2. Cool. So slope is -1 over 2. Great. All we need to do is find b. Now again, it does look like the b could be 1.5, but we're not exactly sure, so we want to use a point that we are sure of to find b, just like we did a few lectures ago. Now, the first point that jumps out to me is this one right here. That's a nice point that jumps out to me. Or you could use maybe this one would work as well. But this guy right here as an ordered pair, x is equal to 3 and y is equal to 0, right? So I can use this to plug into my y equals mx plus b form to figure out what b is. So remember, we have y equals m times x plus b. In this case, y is 0. M is -1/2, x is 3, and we are solving for b. So on the left side, when I multiply these guys out, -1/2 times 3 over 1 is -3/2. And finally, I can add 3/2 to both sides to get b alone. And I end up getting, as we expected, b is equal to 3/2, and 3/2 is the same thing as 1.5. So my equation, remember, all we need are these two things to write the equation of the line. So the equation of this line right here is y equals m, x plus b. And we want to find out which of these lines has a slope of, first of all, -1/2. Remember, it's asking us, hey, find me a line so that when I plot it, these two lines have no solutions in common. That means we want the same slope and we want a different y-intercept. So we want a y-intercept that's different from 3/2. That's what our goal is. Now check this guy out. Do we have a slope of -1/2? Already the answer is no, so that's not our answer. We want both of these criteria so that they won't have any solutions in common. Let's look at the second line. Now we need to do some manipulation to get this into y equals mx plus b, slope-intercept form. So let's do our algebra. Okay, so we have 2y minus x equals 4. I'm trying to get y by itself, so I'll first add x to both sides, leaving me with 2y on the left, 4 plus x on the right. And what I'll do next is I'll divide both sides by 2 to get y alone. So on the left side, I'm left with y alone. That's good. 4 divided by 2 is a positive 2. And this is actually 1/2 x. It's just, you know. So is the slope negative 1/2? No, it's actually positive 1/2. So right off the bat, this is not our answer. We had to have negative 1/2 for our slope. Now let's look at choice C. So choice C, we have 2y plus x equals 3. Let's get y by itself. We'll subtract x first from both sides, leaving us with 2y on the left, 3 minus x on the right. And now I'll divide both sides by 2. Okay, so we end up getting y equals 3/2 minus 1/2 x. Now, check it out. We have the slope. The slope criteria is met. However, the second condition is not met. Our y-intercept is the same as 3/2. We want it to be different. But remember, if the question said instead infinitely many solutions, C would be the choice to pick because it would be the same line. But it says no solutions, so we want to make sure that this B is different. So the answer here is going to be none of these. Oh, not C. None of these. Okay, right? So this is not correct either because they had the same slope and the same y-intercept, but we wanted a different one. Okay, so let's do some more examples here. We've done plenty of these where we solve these algebraically, and I call this substitution because we're basically subbing this in for y and we're subbing this in for y, right? Isn't it true that y equals y? Well, if this equals y, this is 7x minus 1, but this also equals y. This is 3 times x plus 4. So that's my substitution here, and I can solve this pretty easily. On the right, I can clean this up a little by using the distributive property. So 3 times x is 3x, 3 times positive 4 is positive 12, and on the left, I'm left with 7x minus 1. I want to group my x's together, so the first thing I'll do is subtract 3x from both sides, leaving me with 4x minus 1 on the on the left side and 12 on the right side. Now what I'll do is I'll add 1 to both sides, leaving me with 4x on the left and 13 on the right. And finally, I'll divide both sides by 4 to give me my x is equal to 13 over 4. So that's my answer there. If I'm actually looking for the y value as well, I would plug in this for x so into either equation. So if I want the y value, I would do 7 times x minus 1. And let's see what this gives me. 7 times 13 over 4. And again, you can just stick this in Desmos if you want to. This is 91/4 minus 1. And this is giving me 87/4. Ugly number, but nevertheless. So that's my solution. Sometimes on the homework, it'll just ask for x, and sometimes it'll ask for the solution as an ordered pair. So as an ordered pair, you would write it as this. So x comes first and y comes second. That's our answer. What if we're given something like this and you're too lazy to get y by itself over here and then set them equal to? So that's what we could do. We could get y by itself here and set them equal to each other, but that might be too much work. You might have to deal with fractions and stuff. So what if instead since we know this is equal to y, why don't we just punch this in here, right? Because that equals y. Once we do that, we're all in terms of x, and yay, we can solve it. So that's what I'm going to do here. I'm going to plug in y, which is 8x minus 5, into this y right here. So what I'm going to do is I'm going to say, well, since y is 8x minus 5, I'm just going to punch it in for y. And now I can get x pretty easily. So on the left side, I can use the distributive property. 2 times 8x is 16x. 2 times negative 5 is negative 10. And on the left, I can combine these like terms. 16 and minus 3 makes a positive 13x. Minus 10 equals 14. I can add 10 to both sides to give me 13x on the left equals 24 on the right. And finally, I'll divide both sides by 13 to give me 24 over 13. Not the prettiest answer, but you get the idea. So to get my y value, I can use either one of these equations, but this one's going to be much easier because y is already by itself. So I can take my solution, which was 24 over 13, and plug it in for x. So let's do that. So y is equal to 8 times x minus 5. So I'm gonna just do this in my calculator because I'm a little bit lazy. So what I'm doing in the calculator, first of all, I'm doing 8 times 24 divided by 13. I'm writing it just like this. You can use Desmos. And then minus 5, and then, so that's going to be 127 over 13. Again, not beautiful, but that's it. So if I wanted to write my answer as an ordered pair, I could say x is 24 over 13, and y is 127 over 13. All right, let's try some more. So this time my variables are a and b instead of x and y, but that's okay. We don't have to use x and y. Here a is already by itself, so that's the thing I'm going to be plugging in because it's easier to just plug it right in. So since a is equal to b minus 3, I can plug in b minus 3 right in here for a into my second equation. So let's do that. So 3 times a, so a is secretly b minus 3 from the first equation, and then everything kind of carries down. So I'm literally just subbing in b minus 3 in for a into the second equation. Now I'm all in one variable, so that's good. That means I can solve it. And I'm going to start by doing the distributive property. 3 times b is 3b. 3 times negative 3 is negative 9. On the left side, I can combine these like terms. So 3b minus 2b is 1b. And I still have the minus 9. And then I'll go ahead and add 9 to both sides to get b equals 9. Now, to figure out what a is, I can use either equation, but the most practical one to use is the first one. Since I know b is 9, I simply say, well, then a must be 9 minus 3, right? I'm just plugging in the b I found in for b there. So a has to be 6. And that's my answer here. A equals 6, b equals 9. As an ordered pair, since there's not really a convention with a's and b's, I don't know. I would just do it 6, 9 because A comes before B in the alphabet, but yeah. Okay, let's do this one. So first of all, you should pause the video and see which one you think you're going to sub into the other equation. Okay, so the one that we should sub in is the one that's isolated, which is our second equation. We can see y is isolated. So it makes sense to plug in that equation for y, right? Because it's already by itself. So I'm going to plug in y into my first equation. So what I'm plugging in for y is 4/5 x plus 2, keeping everything else the same. So I plugged in my second equation, like the value of y, in for my first equation. Right, this was y in the first equation. Now what I can do is I can use the distributive property, distribute that 5 out. 5 times 4/5, those 5's cancel to just leave me with 4x. So I get 5x plus 4x, and then 5 times 2 is 10. So that's what I get there. Combining like terms, I get 9x on the left plus 10 equals 20. Subtracting 10 from both sides, I get 9x equals 10. And finally, dividing both sides by 9, I get x equals 10/9. Now to figure out what y is, I can use the number for x that I just found. And it would probably make sense to use this one because y is isolated. So y is going to equal 4/5 times, what's the x that I just found? 10/9 plus 2. Okay. So let's see. You can put this in Desmos if you want. It doesn't matter. So let's see. I have 4/5 times 10/9 plus 2. And I get 26/9. Okay, so that's my solution. I have x is equal to 10/9 and y is equal to 26/9. That's my answer. All right, so we talked about the substitution strategy just now. When y, so before, it was easy to substitute because we usually had 2 y's by themselves and we just set them equal. But with the previous examples, we actually took the variable that was by itself and subbed it into the other equation. So that's one way we can solve equations. Another way is called elimination. Sometimes this is a more convenient way to do things. Now, you can use substitution for every single problem if you want, but, you know, in mathematicians, engineers, we always try to do things the simplest way. Like, if there's a simple way, we're going to do it. And, yeah. And, you know, that's what makes math hard for a lot of people, is because people are doing things the more complicated way. And that's just not, you know, that's just, it's just time wasting, I guess. Anyway, so let's talk about elimination. Here's the steps for elimination. I want you to write these down, and we're going to employ these, you know, in the next few problems. The first thing we're going to do is we're going to pick a variable to eliminate. What we're looking for, and I'm going to mention this several times, is we're looking for equal but yet opposite coefficients, such as 4 and -4, 10 and -10, 1 and -1. That's what we're on the lookout for. Then what we're going to do is we're going to eliminate the variable by adding or subtracting the equations together. And finally, we're going to substitute and solve for the last variable. So this can save you a lot of time if you're in the position to, you know, if elimination is the easiest route to go. So let's look at some examples. Solve the system by elimination. Now, as I mentioned, there's multiple ways to do this. You know, if you should know how to do all of this for the final, but but you can always check yourself in Desmos. You can put these things in Desmos and see where they cross, and that's the whole idea. Or what you could do is you could isolate your y's, and you could set them equal to each other. But here, what I'm recognizing is I see two coefficients that are the same but have opposite signs. Can you see what those are? So this is line 1 and this is line 2, okay? Now, what I'm noticing is these coefficients of x are the same number but opposite signs. That's the key. That's the key. So that's the variable I want to eliminate is x. That's the big giveaway there. Now, okay, so we've decided to eliminate x. So we did step 1 because we saw that both of our coefficients of x are the same number yet opposite signs. So I know I'm going to eliminate that. Our second step is to add the equations together to cancel out the variable. So I'm going to just, I want to show you how to do this, and then I'm going to I really want you to understand why we're doing this, because I remember learning this years and years ago and thinking, what are we doing here? Like, is this a magic trick? No, it's just we're just doing algebra and we're keeping everything balanced. So this is step 2. So step 1, we decided we're going to eliminate x. Step 2 is to just add these things down, okay? When I add 2x and a minus 2x, I get a 0x. When I add a 3y and a 5y, I get a positive 8y. When I add an 8 and a 2, I get a positive 10. But hey, check this out. 0y was the variable, 0x goes away. That's what I mean by elimination. We literally eliminated x by just adding these equations together. So what I get is 8y equals 10. And to isolate y, I can divide both sides by 8 and simplify. If I divide 10 over 8 by 2, top and bottom, I get 5/4. So that's that. And then x, I can just plug y into either of the equations to get x. My first equation, 2x plus 3y, I'm going to use that one to get x. So I just found out that y was 5/4, so I'm going to plug it in there. So I get 3 times 5/4 equals 8. And I'm just going to solve this equation. So 3 times 5/4 is 15/4, so I get 2x plus 15/4 equals 8. Now I'm going to subtract 15/4 from both sides. Keep it balanced, and I get 2x equals 8 minus 15/4 is 17/4. And finally, I'm going to divide both sides by 2. So 17/4 divided by 2 is going to be 17/8. So I found x and I found y, and that's my solution. My answer is going to be 17/8 for x and 5/4 for y. So I wanna actually like go back, because I showed you guys the shortcut of just adding the equations down. And I remember thinking a while ago, like, why does this work? And I want to show you why it works. Just kind of like really kind of go into this explanation a little bit more of the why, because I know that some of you are going to want to know. Some of you maybe not, but for those of you that do, here it is. So initially we had 2x plus 3y equals 8. So that was our first equation, and our second equation was negative 2x plus 5y equals 2. And look what I did. I added something to both sides of the equation. So what I added to 2x plus 3y on the left was negative 2x plus 5y. So I did 2x plus 3y. I introduced negative 2x plus 5y. So whatever I do to the left side, I better do to the right side. Well, instead of adding this mess to the right, this mess is equal to this. So I'm just going to add that to the right, okay? And then the elimination works that way. So hopefully that makes sense to you guys, you know, why we're staying consistent with balancing the scale here. Anyway, that's how we do elimination. So let's do another example. So first thing is we want to figure out which of these variables, w or y, are we going to eliminate. So we have equation 1, equation 2. I'm looking for equal but opposite coefficients, and I see them right here, right? I know that when I add these together, they're going to clear. They're going to go away because they're equal and opposite. Positive 6w plus minus 6w is 0. So let's go ahead and add these guys together. So again, I'm adding these guys as step 2. When I add them straight down, negative 4 plus 3y is a negative 1y. These clear. That was the purpose of this. Right? They literally, when we add them, they just clear to 0w. And on the right side, 36 plus 4 is 40. My last step, since on the left I'm multiplying by negative 1, I can divide both sides by negative 1 to give me y is equal to negative 40. So that's my answer for y. Now I can find w by plugging the negative 40 into either equation. I'm going to plug it into the second equation. So our second equation was 3y minus 6w equals 4. And I'm going to plug in negative 40 in for y to figure out what w is. So I get 3 times negative 40 minus 6w equals 4. So 3 times negative 40 is negative 120, right? Let's make sure my math is right. Yeah. Negative 120 minus 6w equals 4 plus 120 on both sides. And we get negative 6 times w equals 124. Divide both sides by negative 6. And I get w equals negative 62 over 3. Okay, so that's my solution. W equals negative 40, y equals negative 40, w equals negative 62 over 3. Again, what you could do is you could check yourself on Desmos, but remember Desmos only likes x's and y's, so you might want to change this to x when you put it in Desmos, and you're going to see that the intersection point is going to be, you know, x equals negative 62 over 3, y equals negative 40. Okay. All right, again, we have two lines where we have, you know, different variables, but we can think of p and r as x's and y's. We treat them the same exact way. So we want to solve this by elimination, and I notice that I don't have equal and opposite coefficients, but what I can do is I can balance my equation. You know, I can do something to both sides of the equation that will give me equal and opposite coefficients. So the first thing I want to do is I actually want to get the p's and the r's lined up, because right now they're not. The 2p is above the r and the 4r is above the p. So the first thing I'm going to do is rewrite it to 2p plus 4r equals 9. I'll leave the top one, and the bottom one I'm going to change to p plus r equals 6, just so that they're lined up vertically. Now, I want to, there's two different ways to do this, but I want equal and opposite coefficients. So I'm going to actually take this equation and multiply both sides by -2 so that I have -2p and a 2p. That's the goal. So let's go ahead and do that. I'm going to multiply, maybe I'll leave this out here. I'll multiply both sides by -2. And when I do that, I'll rewrite this down here. I still have 2p plus 4r equals 9 on top. It's my first line. My second one, if I distribute the -2 in there, I get -2p, which is what I wanted. That was the whole point. And then -2 times positive r is a -2r. On the right side, 6 times -2 is a -12. So now I'm in a good position to eliminate. Because I want to eliminate p since I have equal and opposite coefficients. You could have done the same process to get a -4r if you multiplied both sides by -4, but I chose -2. So what I'm going to do is step 2 at this point. I'm going to take both of my equations and just add them straight down to eliminate the variable p. So I'm going to add them straight down. So that clears that. 4r plus -2r is a 2r. 9 plus -12 is -3. And then I'll divide both sides by 2 to get r alone. So r is equal to -3 over 2. And I can find p pretty easily by plugging r into either of the equations. I'm going to use this equation right here. It looks simpler than the second one because there's negatives involved. Or I could actually use the original. This guy actually probably would be the simplest. So yeah, I'm going to use him, this version. R plus p equals 6. We just found r was -3/2. So we have r plus -3/2. Right, we found p. No, we found r. Sorry, guys. I had that backwards. So r is -3/2 plus p equals 6. Let's solve for p by undoing -3/2, adding 3/2 to both sides. And p is going to equal, let's see. So this is going to be 6 plus 3/2. That's going to be 15/2. So that's my answer. So p is equal to 15/2. So my answer is p equals 15/2, and r is equal to -3/2. All right, let's do this one. So the good news is we don't have to do too much work because I see equal and opposite coefficients in equation 1 and equation 2. So I see that q has, even though it's not written here, there's an understood 1 in front of these q's. So I have a +1 and a -1 coefficient, which means I can add straight down and eliminate them. So step 2, I don't have to multiply anything because I already have equal and opposite coefficients. I'm just going to add straight down. And when I do that, these clear. Now 1p plus 1p is 2p. And 4 plus 6 is 10. I'll divide both sides by 2 to get p alone. And I get p is equal to 5. Now once I have this, I can use either of these equations to get q. I'll use the first one. So the first one says p plus q is 4. I just found p to be 5. So 5 plus q is 4. Let's subtract 5 from both sides. So q is equal to -1. So my answer is p equals 5 and q equals -1. This is where they intersect. Again, these are lines, guys. The p and the q, even though they're weird variables, you can still think of them as x's and y's. All right, let's do this one. So the first thing I'm going to do is line up my x's and y's because they're not lined up as we see them here. So let me line those up. So I have 4x plus 5y equals 19 on top. And on the bottom, I'm going to put the negative 5x under the 4x. And then I have the positive 4y under the 5y, and that equals 3. So that was my first step. Now, looking at the variables themselves, looking at this and looking at this, I see that I do not have equal and opposite coefficients. So I have to create that by doing something, to both sides of one of the equations or both of the equations. So I'm going to choose to eliminate the blue one. So I'm just going to focus on the x coefficients. And what I notice is that the easiest number to get in this case is a positive 20 and a negative 20 because that's their least common multiple. So 4, if we list out the multiples of 4, we have 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 16, 20, etc. And with 5, we have 5, 10, 15, 20, etc. And so the least common multiple is 20. So that's what I'm trying to go for. I want the top to be positive 20. I want the bottom to be negative 20. I actually have to work with both of these equations this time. So, let's rewrite the top here and the bottom. So again, my goal is to make the x coefficients. I want this one to be 20, and I want this one to be negative 20, so that I can eliminate. So on the top, how do I get 4? What do I have to multiply 4 by to get 20? Well, I have to multiply it by 5. And whatever I do to one side, I better do to the other side of the equation. So let's actually just keep rewriting the new versions. If I distribute the 5 here, I get 5 times 4x is 20x, which is what I wanted. 5 times 5y is a positive 25y. And 19 times 5 is 95. Okay. The second equation, I wanted this negative 5 to turn into a negative 20. So to do that, I better multiply both sides by a positive 4. And when I do that, when I use the distributive property on the left, 4 times negative 5x is negative 20x. 4 times a positive 4y is a positive 16y. And on the right, 3 times 4 is 12. And now I'm in a position to eliminate because I have equal and opposite coefficients on x with this new version. So what I can do is I can add straight down, eliminating those variables, and 25y plus 16y, I'm going to be lazy and use my calculator, my brain's not optimal today, but that gives me 41y, and 95 plus 12 is going to give me 107. Finally, I'll divide both sides by 41 to get y alone, and I get a fraction, 107 over 41. That's all I can do here. So that's my y. Now to find x, I can use any version of either equation to plug in y and get out the x. I'm going to go to the lower numbers just because it might be easier that way. I'm going to use this equation up here. Now I just found I found y was 107 over 41. So what I have is, if I plug in y into this guy, I have 4x plus 5 times 107 over 41 equals 19. And I want to solve for x. So when I do this multiplication, 5 times 107 over 41, I get ugly number, 4x plus 535 over 41 equals 19. I'll go ahead and subtract this ugly 535 over 41 from both sides. So I get 19 minus that. So I end up getting 4x on the left equals 244 over 41 on the right. And finally, I can divide both sides by 4. And again, do all of this in Desmos or your graphing calculator because we don't need to do all of this by hand. So there's x. So our answer here is x equals 61 over 41, and y equals 107 over 41. This is my answer. All right, let's try this one out. So my x's and w's are lined up, which is a good first step. But I noticed that, you know, I can't change a 3 into a 7, and I can't change a 5 into a 2, or vice versa. So I want to use that least common multiple strategy. So what I can do is I can focus on these. You know, you could do the other ones, but I'm going to focus on the w's. And I want to find the least common multiple of 3 and 7. So for 3, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 12, 15, 18, 21, etc. And 7 is 7 times 1, 7 times 2, 7 times 3, and I stop because I found a match. 21 is the least common multiple. So my goal is to make this a positive 21, and I want to make this a negative 21. Or you could flip it, doesn't matter. We just want one to be positive and one to be negative so we can add them and eliminate. So what can I do to make the top equation the coefficient 3? What can I do to make it a 21? Well, I can multiply it by 7. So what I'm going to start by doing is I'm going to multiply both sides by 7 so that I can achieve my goal of making this a positive 21. Okay, so when I do that, whatever I do to the left, I have to do the right. Okay, and so on the left, I can distribute that 7 in there. 7 times 3w, we get 21w, our goal for the first one. And then 7 times negative 5 is negative 35x equals 2 times 7 is 14. Okay, good. So this, I'm going to just rewrite the first equation as 21w minus 35x equals 14. Now for my second equation, my goal is to make this guy a negative 21. So what can I do to both sides to make that 7 a negative 21? Well, I can multiply both sides by a negative 3. So when I do that, so when I distribute on the left, negative 3 times 7w is a negative 21w, which I wanted. A negative 3 times a negative 2x is a positive 6x. And on the right, 0 times anything is 0. So this is my second equation, and I'm in good shape here. Okay, so my system, an equivalent system that I use just by balancing the seesaw, is on the right. And from here, I can go ahead and add these guys because of the opposite equal coefficients. So when I do that, those cancel. Negative 35 plus 6 is going to give us a negative 29x. And a 14 plus 0 is going to give me 14 on the right. I'll divide both sides by negative 29 to give me x equals, dun 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 dun. Let's see, negative 14 over 29. can't be simplified. So we found x. Now we need to figure out what w is with either of these equations, any version. I'm just going to use the first one to keep it simple. So w is 3. We have 3w minus 5 times x. We just found x. It's negative 14 over 29 equals 2. And we want to solve for w. So negative 5 times negative 14 over 29. Let's see. I'm getting positive 70 over 29. Okay, and then I'll subtract 70 over 29 from both sides to get the w alone. So 2 minus 70 over 29. Okay, so what I get on the left, I'm just left with 3w, and on the right, 2 minus 70 over 29 is negative 12 over 29. And my last step here is to divide both sides by 3 to get w alone. And again, I'm just using the calculator to do all of this. All right, so that's my w. I have x, so my answer is x equals negative 14 over 29, and w equals negative 4 over 29. Okay, so one cool thing about systems of equations is that we can use them to figure out word problems. So let's go ahead and look at a few different examples of how we can use systems to solve word problems. So it says the cost of tickets to a play for 1 adult and 2 children is $48. The total for 2 adults and 3 children is $82. What are the individual ticket prices for adults and children? So we need to first set up variables and say what they mean. Since we're looking for ticket prices, we know that those are going to be our variables. So we can let x represent the cost of a child's ticket, and we can let y represent the cost of an adult ticket. So we're doing the same thing that we've been doing. We're looking for x and y, but we're looking for it in a real-world context. So the next thing we need to do is actually write out the equations that we're going to solve from this information. So the first sentence says that the total for 1 adult and 2 children is $48. So how do we write that in equation? Well, we can say we have 1 adult and we're going to multiply by the cost of the adult tickets, which is y, plus 2 children, so 2 children times the cost of the children's ticket, and that total equals, it's going to be 48. So this equation that I just wrote is going to coincide with the first sentence. Now the second sentence is going to give us another equation, and try to figure it out before I give it to you. The total for 2 adults and 3 children is $82. So we have 2 adults this time, so we have 2 times y, so 2 adults times the price of the adult tickets, plus 3 children times the cost of the children's ticket is $82. Okay, and here's our system of equations. We have equation 1 and equation 2, and we need to just solve this. Now again, if you put these two things in Desmos, Desmos is going to give you the intersection. It's going to give you the answer for x and y. What I would recommend doing is, using a strategy that you're comfortable with to figure this out, because it doesn't specify. Now, I'm going to get rid of this 1 in front of the y, and I'm just going to say, well, it looks like y is pretty much isolated with equation 1. All I have to do is subtract 2x from both sides. So I'm going to actually do a substitution here because that's the most obvious thing that I see to do. is to get y alone, because it's pretty easy to get y alone. And you could do elimination if you wanted to. You could just use Desmos, it doesn't matter. But what I'm going to do is I'm going to get y alone with the first equation by subtracting 2x from both sides, and therefore I get an equivalent equation of y equals 48 minus 2x. And what I'm going to do is I'm actually going to substitute that guy in here to figure out what x is. So, using my second equation, I'm going to say, well, y we just found to be 48 minus 2x. And the point of doing this is to get everything into one variable so that you can solve, and this one variable is x. So I'm going to go ahead and draw that line. I'm going to distribute this guy. So yeah, I get 96 when I distribute, minus 4x plus 3x is equal to 82. And then combining like terms, I get 96 minus 1x equals 82. I'll subtract 96 from both sides to give me negative x on the left side equals 82 minus 96 is negative 14. And finally, I'll divide both sides by negative 1 to give me x is equal to positive 14. So what was x? X was the cost of the child's ticket. So this is going to be $14 a piece. We just found x. Now for y, the easiest equation version to use is this one right here. I know that x is 14, so let me just plug it in there and figure out what y is. So this is going to be 20. So the cost of an adult ticket is 20. Now, I just want to, so that's one way of doing this. You could have used elimination, you could have used Desmos. I'm going to show you the Desmos way, which I think you guys will agree is the easiest way to do these word problems. We just literally just plug in each of these into Desmos. So y plus 2x equals 48. Let's do that one first. And then our other equation is 2y plus 3x equals 82. Okay. And then we can zoom in and see their intersection. So as we can see, X, which we said was the children's ticket, costs $14, and Y, which is the adult ticket, costs $20. So that's probably the simplest way to do that problem if you're not given specific instructions on how to solve it. Okay. Find two numbers with a sum of 17 and a difference of 12. How are we going to do this? Well, we can set up a system because the two numbers are unknown, and we can set up a system of two equations by saying, well, I'm trying to find the sum of two numbers, two unknown numbers. So let's call the unknown numbers x and y. I want the sum to equal 17, but at the same time, I want the difference of x and y to be 12. So those are my two equations, my two lines. Now, once again, if you plug these two lines in Desmos, it's going to give you your answer. It's going to give you x and y, your intersection. However, my gut instinct is to use elimination because what I see is a positive 1y and a negative 1y. And so that tells me I can eliminate this pretty easily by just adding straight down. So 1x plus 1x is 2x when I add straight down. These cancel when I add straight down. 17 and 12 adding is going to be 29. And what I can do to both sides is divide both sides by 2 So 29 divided by 2 is going to give me 14.5. And once I have that, I can use either of the equations. So how about we just use x plus y equals 17. We know what x is at this point. X is 14.5. So we have 14.5 plus y equals 17. I can subtract 14.5 from both sides, and I get my answer. I get y is equal to 2.5. Okay, so if I add these two numbers up, I do get 17. If I subtract these two numbers, I do indeed get 12. Okay, so that's how we can solve problems like that. So let's do one more problem where we can use systems to solve. So candy canes cost 50 cents per pound, chestnuts cost $1.25 per pound, and lumps of coal cost $2.50 per pound. I buy twice as many pounds of chestnuts as lumps of coal, and I buy 10 pounds of candy canes. I spend 15 bucks in total. How many pounds of lumps of coal do I buy? So I know that my variable is going to be pounds. So let's name variables for each pound component. Now, pounds of lumps of coal, I can say that's x. So I can say let x be the pounds of coal. So I'm trying to find x. X is pounds of coal. What about the other pounds? Well, I can say that y is the pounds of chestnuts. And then I'll give another variable for the candy canes. I can say that z is going to be the pounds of candy canes. Okay, so those are my variables. Now I need to use this little paragraph to set up some equations. So candy canes cost 50 cents a pound. Chestnuts cost $1.25 per pound. Lumps of coal cost $2.50 per pound. And I spend $15 in total. So I'm looking at the first sentence and the last sentence to sort of combine these into an equation. Now, the way that I can do this is I can say, well, since candy canes are 50 cents a pound, I'm going to say, well, 0.50 for 50 cents times the pounds of candy canes, which is z, plus, now the next one says chestnuts are $1.25 a pound, so 1.25 times y, plus how much coal, so $2.50 a pound for coal, and that total is going to cost me $15. Okay, so that's one equation that we have here. What else can we say? It says, if we look at the second sentence, it says, I buy twice as many pounds of chestnuts as coal and 10 pounds of candy cane. So that tells me some information. Twice as many chestnuts as coal. So that's going to be twice as many chestnuts as coal. So we have 2x equals y. See if that makes sense. So twice as many chestnuts as coal. So if I buy 8 coal, I have 16 chestnuts. Does that make sense? Yeah, twice as many, twice as much chestnuts as coal. So that's my equation there. And also it says that we buy 10 pounds of candy canes. And so since z represents the pounds of candy canes, z is going to equal 10, right? And so I can replace that in here. I can say, well, since z is 10, I can just replace that in there. So that's it. I have 2 equations. I have 2 unknowns, x and y, and I know how to solve problems like this. Now, for me, it's tempting to use substitution because I see a variable by itself, which is y. So if I plug y in here, I can solve for x. So let's go ahead and do that. First of all, so I'm using equation 1. 50 cents times 10 is going to be what? Is going to be 5, right? So I have 5 plus 1.25. Now y is 2x. So I'm going to sub in 2x in. The goal is to get everything in either just x's or just y's. Again, guys, these are lines you can put in Desmos to check. So if I draw my line here, now I can multiply these out. 1.25 times 2 is going to give me 2.5, so I get 5 plus 2.5x plus 2.5x equals 15. Combine these like terms to give me 5 plus 5x equals 15. And finally, I can subtract 5 from both sides to give me 5x equals 10 and divide both sides by 5 to give me x equals 2. So that's my answer because x was pounds of coal, so x is equal to 2. This is my answer. How many pounds of coal do I buy?